All right, so we're going to talk about section 1-2 today, which is line segments, distance. Okay, so now we'll get a little more specific with our definitions and a little more, deal with a few more numbers. I know some of you like that a little better. Some of you like the geometric shapes. Again, some of this is going to seem obvious, but it is completely and totally necessary that we do some definitions and we define some things and that we are all talking the same language as we describe these things, and that you properly know how to name and call these different geometric figures, okay? So the first thing we need to talk about is a line segment, okay? So what is a line segment? The line segment is exactly what it sounds like. Essentially, it is a piece of a line, okay? It's not infinite. Remember, a line goes on forever and ever, right? If I have this line, it goes on forever and ever and ever. But a line segment is simply a piece of that line, okay? Or a part of that line. It can be measured because it has endpoints. Okay, so maybe this is, come on, point T on the line, and maybe this is K. And so this I could name as line segment TK. I put a line over it. Notice the arrows aren't up here because now it's a segment. It's not a line, okay? TK is the same thing as KT, and I can name my segment that way, okay? Different now, if I kept this line going the whole time, I could still describe this way as a segment, but here's a line, and again, either way would be fine. So I hope you see the difference here, segment and line, right? Okay. Now, we need to talk, and this is going to sound really strange whenever I say it, okay, so y'all bear with me. Betweenness. Betweenness, okay, of points. And I'm sure we all know what between means, okay? But the betweenness of points, if points are between, if there is a point between two other points, so let's say that I have, let's take my line here, and let's put some points here. H, I, and J, okay? From here to here, okay, this is line segment HI, right? This piece here. This piece is line segment IJ, right? The whole segment would be HJ. Those are all different line segments, right? Well, I can conclude that point I, right, that's the point in the middle of these two, is between, and I mean clearly we can see it, but remember we have to be very specific and write things out in geometry, and it will make a little more sense a little bit later, is between points H and J, if and only if, and this is something you will see a lot in geometry, if and only if. Sometimes, and if you see me write this, I'm going to make a little side note here. Come on, if it'll change colors. Sometimes you will see me write IFF, okay? That means if and only if. It's just a little shorthand for if and only if, so you don't have to write that whole little phrase out every time, right? All right, so if you see that, you know what that is. All right, so point I is between points H and J if and only if I, H, I and j are collinear. And remember, what does collinear mean? On the same line, right? So if and only if they are collinear and hi, where is hi? That's the first little small piece, right? Plus ij, that's the second little small piece, equals the whole thing, right? hj. My pen, I'm kind of out of room here. So if you can add the two little pieces together, the two segments, this one, and they give you the whole, then that tells me that this point is between the ends. Okay? All right. Lots of things we are going to have to justify or prove or tell why. Okay, so the definition of between means that you can split the segments up, add them together, and they give you the whole, and the point is between. Okay? All right. So let's do an example. Let's say, again, this is going to look so easy, but bear with me. Let's say I've got this line, and I have some segments on here. E, F, and G. This is 2 3/4 inches. This is 2 3/4 inches, right? How might you find the measure of segment EG? You want to pause and mark this? I hope this one's easy enough for you to see. Well, clearly, I would just say 2 3/4 plus 2 3/4, right? Would give me 4 6/4. 6/4 is 1 1/2, so I would have 5 1/2 inches for that one, right? So EG is 5 1/2 inches. Maybe I give it to you the other way. Maybe we have a line segment, and we have LMN, and maybe this is, maybe I tell you that the whole thing is 12.1 inches, and maybe this little piece MN is 2.3 inches. And I said, what is the length of segment LM, right? So if we know that M is between L and N, then we know that these two pieces, these two segments add together to give you the bigger segment. So to find LM, I would need to take 12.1 and subtract 2.3 to find the length there. And when I do that, I get 9.8 inches, right? Easy peasy. Let's make it a little bit harder. Let's put some algebra in here. Let's say I've got this segment. I already did HIJ, didn't I? Let's do D, E, F. Okay? Let's say that let's first define and say that point E is between, well, if I can spell, points D and F. Okay? And let's say that DE is 2x wrong. So this area here is 2x. Let's say that EF is 12. Okay, and let's say that the whole segment DF measures x minus 5. It's for this whole segment. How might you find the value of x and in turn the length of each segment? Okay, so because I have defined point E to be in the middle each time, what I want to do is set up an equation, right? Because DE plus EF should equal DF since E is between D and F, right? All right, so DE is 2x, EF is 12, and it should equal x minus 5. Oh dear. And y'all, I made this up off the top of my head. Come back, let's change this to 3x here. Let's change DF to 3x so this actually works out for us. DF to 3x. I apologize for that. Just make a little note in your notes. Just add that 3 in there. It shouldn't be too hard for you if you need to pause a second. Okay, so let's solve it for x. Okay, so let's move this x to this side, so I need to subtract it. So now I have 12 equals x minus 5. And if I add the 5 to both sides now, I find that I'm out of room for 1. But I find that 17 equals x, okay? Now, if 17 is x, that still hasn't answered the question I asked in the beginning, which was, what is the length of each segment? So let's go in and fill in what we know. If x is 17, that means that DE, which is 2x, right? DE is going to be 2 times 17, so DE is going to be 34. Then if I go through, let's see, EF. EF is already 12. That's already solved for us, right? So now let's find the length of the whole segment, DF. So you could do this one of two ways. You could go ahead and add these two together, right? DE and EF. And it should give you the same thing. And let's just do a double check because 34 and 12 would be 46. If I do 3x minus 5, that would be 3 times 17 minus 5. And let's see, 3 times 17 would be 51 minus 5, which is indeed 46. So those match, so that's perfect. Okay? All right, so let's talk about congruence for just a minute. Congruent is a huge geometric concept that just means that shapes or figures are exactly the same, okay? So, geometric, and by exactly the same, what I mean is the exact same shape and size. Everything about them is exactly the same, okay? Now, we have what we call rigid transformations, okay? And what that means, it sounds worse really than what it is. a rigid transformation means that you can move a geometric figure, okay, and move its position, but even by moving it, it can still be congruent. In other words, let's say, let's take congruent line segments, okay? Let's say that line segment A, let's say that line segment AB, let's say that these two are congruent, okay? If I move them around, if I were able to literally pick them up and move them around, they would still be congruent because their size and their shape has not changed at all, okay? So let me show you how we would indicate that things are congruent, okay? And there are several ways, and it's really, really important that you mark this in your notebook and that you remember how to do this because you will see this a lot, okay? Congruent segments are marked with a line, okay? That line lets us know that these two are congruent, okay? And then sometimes if you have more than one, you might put another line so that I know the one with two lines, those are congruent, all right? So that's how we mark the segments themselves. And since we only have one set of segments here, we'll only mark them one time. As I name them, I use special symbols to congruence. We would name the line segments. So I got line segment AB, and it looks kind of like an equal sign, but above that equal sign, there's a little squiggly line above, okay? And that lets us know congruent. And congruent is different than equal, so don't get those confused. If you said that AB equaled CD, that would just tell me that their lengths are the same. And remember, I'm not talking about length, I'm talking about size and shape. Congruence means everything is exactly the same. So make sure you use the correct symbols there as you describe your line segments, okay? Now, last thing about line segments is we will talk about distance between points, specifically on a line between, as like the length of a line segment, distance between points. Now, as you know, distance is never negative. So what I want to do is make sure that the distance is never negative. And as you know, if I've got a line, and let's say this is point P and this is point Q, so I'm talking about line segment PQ, okay, this distance in between. Let's give it a coordinate. Let's say this is a number line and I give it a coordinate. So let's say this is 2 and this is 8. How might I find the length of PQ? And so if you said to find PQ, I would subtract, you're exactly right, okay? I would need to subtract 2 and 8. But the question is, does it matter if you do 8 minus 2 or 2 minus 8? And the answer is, as long as your absolute value, which makes everything positive, because remember distance is not negative, then it does not matter. And so my distance here is 6 regardless. Okay, so I have absolute value of 6, which is still just 6, okay? So in general, the formula between points, let's take this same number line and let's call point P, let's call its coordinate x1, let's call this coordinate x2. So to find the distance or the length of PQ, I want to do the absolute value of x1 minus x2, or I could also say x2 minus x1. Absolute value, right? Because absolute value is most definitely describing distance, because it's always. Last concept here, to find distance on a number line is easy. If I move into a coordinate plane, however, it's a little bit trickier, but it's still not too bad, okay? So y'all stay with me. I'm going to give you the formula. I'll do one example, and I promise I will be done. Let's say I put this line segment not on a number line, but I took that same line segment and I put it here in a coordinate plane. Here is X and Y. And I'll call this X1, Y1, and I'll call this X2, Y2. And so what I want to do is I want to find the distance or the length of segment PQ still. And so I'm going to give you a little formula. And I think it'll be easier if I just give you the formula and then we work through an example and you see how it's done. So to find the distance, I use this big long distance formula. It's going to look worse than what it is. Everything goes under a square root. I'm going to subtract the x's, and again, the order of the x's here doesn't matter, but this time it's because I'm squaring it, so I'm going to always make it be positive. And to that, I'm going to add the difference of the y's, and I'm going to square that as well, okay? So subtract the x's, square it, subtract the y's and square them, and add them together under a radical, okay? Let me show you an example because I know that that formula can be quite intimidating when you first see it. All right, so this is, if you want to label this in your notes, by the way, this is the distance formula. All right, so let's say, for example, I have a line segment. Let's say I have segment XY in the coordinate plane, and let's say that X has the coordinates 2, 4, and that Y has the coordinates -1, -3. Okay. To find XY, and if you want to try this one on your own and pause the video and then come back, that would be wonderful. But let's see. Let's find the distance between these 2 points. Square root. Remember, I'm going to subtract the x's, so I've got 2 minus -1, and I'm going to square that. To that, I'm going to add, and then I'm going to do the same thing with the y's, right? 4 minus -3, and I'm going to square that. Now let's simplify. So remember your order of operations here. Be very, very careful. I want to, oh my goodness, my screen's jumping everywhere. 2 minus -1, we're going to do these parentheses first. So I have 3 squared, because 2 minus -1, right, is 3. Plus, and 4 minus -3 would be 7. Now I'm going to square each one. 3 squared is 9, 7 squared is 49. So I find that the length of segment XY is equal to the square root of 58. And I am done.